And welcome back to the SEI virtual event, Cyber COI Alignment or Challenges and Gaps. This is our final presentation for today. It will be a DevOps panel moderated by SEI CTO Dr. Kevin Fall. And just a reminder for everyone, if anybody's just joining us, to take a look at that Files tab where you can download the resources from today's event. And also, upon exiting today's event, please fill out our survey, as your feedback is always greatly appreciated. Now I'd like to introduce Dr. Fall. He's the Deputy Director and Chief Technology Officer of the SEI, where he directs the research and development portfolio of the SEI's technical programs in cybersecurity, software architecture, process improvement, measurement and estimating, and unique technical support to sponsors. Joining him as panelists will be Joe Yankel, who is a team lead within the Secure Lifecycle Solutions team here at CERT, and also Hassan Yassar, who is the technical manager of the Secure Lifecycle Solutions group here at CERT, the CERT division within the SEI. So now I'm going to turn it over to Dr. Fall to get us going.
Okay. Thank you, Shane. Good afternoon, everyone from Pittsburgh, Pennsylvania. We're going to have a discussion here about DevOps and its relationship to cybersecurity and the dynamic threat. So I thought maybe we'd just first start off by just saying and sort of level setting with what do we define DevOps to be?
Yeah, so the DevOps is actually it's a very industry term known, and its a basic definition is the emphasized communication, collaboration, integration between software developers and information technology and operations personnel. So it's an industry term. However, DevOps is an extension of Agile methodologies. It requires a lot of knowledge and skills necessary to take the project from inception throughout the sustainment and to be continued within a dedicated project team. So it's a practice to enable the team to achieve the level of coordination and understanding necessary to automate infrastructures. So it's a kind of like industry term known, but we would like to really cover up the process and methodologies. How can we get that process methodologies, automation, especially how industry is deploying in a faster and quicker release in a large-scale application. We would like to get that deployment automation techniques into the agile operation of the cyber threat or cyber maneuvers and make it faster and real, that type of thing. We would like to get a DevOps in that realm. So there's the basic principles of DevOps, and these are the collaboration, infrastructure as a code, automation, and monitoring. So these are 4 principles of DevOps, and mainly infrastructure as code and automation will be really directly addressing the dynamic cyber threat and then vectors. So. And can I add anything else, Joe, you want to add it too?
No, we'll continue on with the, get a little more in depth on infrastructure as code.
All right, so this second item is infrastructure as code. So how does that relate to the automation aspect for DevOps?
So infrastructure as a code definition is kind of scripted configuration of systems and environments. So what basically means, and based on the technology changes and virtualization, that makes enable to have the configuration of environment. So what environment means can be a virtual host, can be any applications reside on it, can be a really testing platform, can be infrastructure, can be a network platform. That can be all scripted and all configured. So it depends on the changes, and instead of really manual configuration, so a script that can run automated configuration, push any VMs on the fly, or it can push any environment on the fly, including network configuration and some of the switch configuration, possible network changes, then on the fly and then move it. So it's basically scripting all the infrastructures, have a code and put in repositories and change it dynamically. That's we can describe that way. So basically the main goals and technical challenges is really have some sort of configuration. So if you give configuration is treated as a code in the platform, it's easy to deploy it and then easy to monitor it, easy to versioning and then change it dynamically. So basically I'm going to jump to the benefits as the describing. So in a general known term, it can be a development environment, operational team, security team. So in a practice way, that can be multiple section of the configuration of environment. Can be application, as I said, can be a network configuration, or it can be a platform and dynamically change it and depends on the needs.
Okay. So given the DevOps cadence and then with the automation and infrastructure as code, we're faced with a dynamic sort of evolving cyber threat that changes regularly. How does those type of capabilities allow us to better counter some of the threats that we might face?
Yeah, I can speak to that a little bit. So one of the things we're going for with DevOps is an infrastructure as code is we want the ability to quickly deploy our applications, continuously update them, and deliver those. So in the case of maybe a dynamic changing threat, if we can detect those things, then we can have the action of if our infrastructure is checked in as code, we can then dynamically push out a new infrastructure immediately. So the idea here is that I make a small change in software. I don't only deploy that one application, I actually deploy my entire environment, my network, those applications, their IP addresses. They all can be pushed dynamically and basically give me a brand new system. So systems of systems can be built on the fly. So we're going for continuous delivery, continuous deployment. That means every change I make, I can build my entire system. So we've often approached dynamic changes with just building specialized software to reconfigure itself. Well, in DevOps, every day we want to possibly push out a brand new build. Using those techniques, we could essentially, we've detected a threat. Why not rebuild our environment, the entire thing? So it's kind of a different way of addressing something we do every day in software development using agile approaches in DevOps to get multiple builds per day, for instance. We could have an environment deployed at the push of a button. So we're really going for speed here. Currently,
And agility.
speed and agility. Currently, it's a manual process. We detect a threat, a human actor gets involved, makes manual configuration changes. But with DevOps, we've already implemented a lot of tooling, automation, scripting to build this environment up. So even a minor change can give me a new environment. Well, why not trigger a new environment based off of threat detection? I've detected a threat. I've been compromised. Well, I'll deploy my environment again. If my host was compromised, that host is gone. I have a new host running the same code or an updated version of the code. So that's where we're going with DevOps and the next phases of helping the COI here.
And I've looked at a couple other things as well. As you described, it's really getting a faster automation and deployment, how industry is addressing the application deployment, a faster release in a large-scale environment, large-scale user-based, and taking that concept and using a threat vector. So if there is any threat changes, depends on the size, depends on the complexity. Maybe we can throw out the whole application suite, or we can just have the minor configuration. That can be a IP configuration changes on a box. That can be some application configuration changes. The other things, if you know some simulated variable before, by changing the variables, and we can push the new application settings probably. Or if you know the signature of any threat that we captured, we can do some sort of automatic changes on a machine itself. Then we can throw another version of application or infrastructure in a faster way. As we know, that speed is really important. And one of the topics in cyber maneuver is really address the needs in a higher speed and as quicker way as possible. To achieve that is a quicker way and the faster way, we have to have some automated machine behind it, which is a machine has to do that, which is a PC has to do that, which is what's happening in the industry, and take that concept, putting the cyber threat environment and change it dynamically.
Okay. So the DevOps framework and infrastructure as code has been largely focused on infrastructure in the sense of VMs, computing platforms, endpoints. Certainly the cyber threat is applicable to the network infrastructure as well, and we've got at the same time software-defined networks and other kinds of more programmable infrastructure. What's the relationship of that type of DevOps and infrastructure as code part with what could happen with more dynamically programmable network infrastructure?
So the networking configuration, think about any firewall box, any other switch. So if we have a versioning on that box itself, and then we can change the firewall rules on the fly and depends on the threat, and we can deploy a new version into box. It can be maybe a standalone machine itself, and again, changing the configuration and deploy dynamically, and that configuration is going to be treated as a code. So we have a versioning. So we can go back, and if threat is changing again, we can go back to the previous version or a different version that we planned before and push it dynamically again into the network environment. It can be one of the servers, it can be many servers. So also other things, and it's very industrial things is using right now is a Docker container. So we can treat it as an application as a container and then throw into another host maybe. Let's say if the host is compromised, then we can throw another host and throw an application into it, and then it has configuration in it, so that can be stand up another environment as a part of the OS or a part of the configuration of the network. Anything else you want to, Joe?
I think you're on, that's the track we're thinking, is that if we currently it's not addressing necessarily building a network out, but why not? We can script almost any changes in the network, so why not consider those to be vital pieces of our, that infrastructure should be committed as code. Therefore, changes to that can be made on the fly also. It's just one more step in the evolution of creating not just applications but systems.
Right. It strikes me too that there's this move toward network function virtualization where you're, eliminating the standalone boxes and moving some of that functionality into the infrastructure, which should, it would seem to me, lend itself directly to all these kind of benefits in the same way. So are there specific, maybe along those lines, are there specific processes or tools or capabilities that you might recommend or that you're familiar with that you'd like to talk about for people?
Well, virtualization is big. It's enabled everyone to begin to quickly try these things. We don't have to rely on having so much bare metal to do the configurations. So I'd say important step, we should be virtualized at some point, and that allows us for quick reconfiguration of machines. Next is just evaluate your current processes. I don't know, I guess we see there could be a DevOps scale. How DevOpsy are we? We're just talking about agile methods. We're talking about, can we make quick changes from a requirement to having a brand new application? How long does that take your current your system, your project teams? How long does it take to implement a change? Well, here on some of my project teams, you ask for a requirement. If my coders can do it quick, say an hour, well, an hour and a half, I have that build up in production, ready to go. So when it comes to speed, it's the only way. First thing to do is, how long does it take me to deploy our new system, our new software, in our current infrastructure? You might want to ask that question, are you even close? The answer is often no, we're nowhere close. It takes 6 months to get a change. So we need to look at our tool sets. We want to find out, can we build? Will a change in source code, will it result in a brand new build? This is continuous delivery. We want to get to that. I'd say that's step one when we're talking tools. Step two is far away from most folks. This is continuous deployment. That means my code change is not just delivered in some fashion as an executable or a web application, but put out there for the public, for general use. That's pretty advanced, but that's where we want to get. And if we get there in all our systems, we create, and this involves a re-architecture. We want smaller services, microservices that can be spun up and deployed. Changing a little bit in the way you architect does lend itself well to doing this. Large systems, they take a lot of time to get to the level where I could easily change the entire system based on, say, a threat.
And I think these are the common tools that we can use in industry standard, like the Jenkins integration server. Mainly, Docker is a really great tool, and have self-contained environments and deploy into the new infrastructure or new servers. And along the other things, I would like to touch point is actually one of the technical challenges is the collaboration and the coordination between the multiple actors. So using the same similar techniques in software development, like having a cross-platform, common platform, get all the developers, like in that case, all the actors in the same collaborative platform, they can share what they're finding out, and then it's possible to automate that, find their findings, and tie into the application itself. That application is deployed based on the configuration. So all the actors, they're going to share what they're finding out, threats, and correlate together in a common platform and share it across other team members. So that can be automated. And how it's happening in the industry right now, let's say one of my developers or together, if he find any bugs in the system, we are collaborating through our system, issue tracking system like Jira or some other things, then we are able to collaborate that. Or we can use some sort of chat software, we can collaborate that. So once we collaborate, and it's possible to stand up another build, and push into the application directly to the production or a staging environment. In that case, we can really throw the new application sets and based on threat and into the environment, so we can address dynamically new threats. It's going to be like the speed of the application in the machine is going to do by itself. Depends on the power, depends on the network configuration. It can be a short time frame, it can be a big, but at the end, it's going to be much faster than the human. Instead of having a one person or multiple person, it's going to be much faster in a large-scale environment, that we can say.
Okay. Is there a...
We have an audience question from John asking, just we can go back to what were the 4 elements for DevOps. He got the first 3 of collaboration, infrastructure for code, and automation. What was the 4th again, Hassan, if we could?
So in the industry known standard, there's the 4th one is monitoring. So I'm just going to go over again the 4 principles. Collaboration is really a key point. Collaborate all the team roles and team members. The second one, infrastructures, which we describe well, and automation is another task which we're talking about, automation of the process and workflow. And the 4th one is monitoring. So actually a good topic that we can talk. If we monitor the environment, application itself, on the server configuration. So I know there's a lot of IDSS platform or the monitoring platform in cybersecurity things. So if you tie into our application configuration, let's say if we capture anything that we are expecting or we can have an alert can trigger some configuration on the application itself, then either we can deploy the new one or we can understand that machine is compromised. So if we kept infrastructure as a code and separate out the data in another server, if you know that server is compromised, we know nothing happened to data, we can capture immediately and throw another server, which is a monitoring capability. So it's really a good component having a monitoring throughout the application suite and throughout all the monitoring capabilities as part of the process.
Okay. So one other question in the queue, just from Joe asking, how often is DevOps used in the DoD environment now? Is that something you guys see a lot? Are you going in and pushing that with customers
It's
now?
a perfect question. I was talking with Joe this morning, actually. It's a very new concept for DoD space. It's very well known in the industry. And how the Netflix, how the Amazon, how the Google are doing right now. We would like to get that concept into the DoD space and addressing agile operations. It's much better. So it's not really as known in the DoD yet. And it's still they are trying to get agile process and stuff, but we would like to get the DevOps tools and methodologies using in the cyber maneuver techniques and addressing that needs basically.
And you had the slide with all the tools. Is that something they have trouble getting access to those tools? Is there limitations that they meet that they can't
actually,
access?
It is not. There is no limitation. Some of them is open source. Some of them, even though some government folks, not the DoD, and some civilian agents are there using it already right now, it's a matter of changing their process, matter of their application, as Joe described. If the application is microarchitecture level, it's a modular, yes, there is a way to get that tools and use it. It's just a knowledge base. It's not really as protecting anything else, I believe.
Okay.
It's open source. Some of them is open source. Some of them is configurable. The other things that has to be picked based on based on the environments what the DoD folks has, and then we have to use the proper tools for that environment. So we cannot really get any of the tools and use it. But if anybody using the VM, and most of the tools like the Chef and Puppet is capable to that type of work, like Chef, Puppet, it's possible. And if anybody's using Linux environment, it's perfect to do as well, Chef and Puppet. If anybody using any, like a Windows environment, Visual Studio, Team Foundation Server is a part of that. It's possible too. So like other Docker container, Docker can work in the Linux environment, can work in the Windows environment as well. So it really depends on the environment configuration. It's possible to do that.
Okay, so that cleaned up the queue. So I'm going to turn to Kevin and maybe let him grill you on some of your work. Come up with a question, put him on the spot,
Okay.
and while we have about 5 minutes here to finish up, any closing thoughts, or let Kevin take it.
So let me revisit the question I kind of got to before. So I originally came from a networking sort of point of view or background, and the evolution there had been from fixed function sort of devices, and actually in the way back they were programmable, but then they were fixed function with higher performance. And now you're getting this software-defined networks where things like routers can be changed. They can change flows. And now the next evolution that's been discussed, this network function virtualization, is to take those fixed function boxes like intrusion detection and load balancing and stick them into the rest of the infrastructure as code. So if you start to now have the data flow elements next to the end processing elements all shared in the same racks and maybe cloud computing infrastructure, what kind of performance issues are we going to have to be worried about? What kind of security issues are we going to have to then worry about down if we have, might we someday get to the point in the DoD setting where we have multiple different kinds of networks that we can actually process together?
It's a good question. We do have to be concerned with the security. We're aware of it. I think what happens is we skirt it. We don't actually take care of the problems. We actually know how to handle almost every situation. It's just that it isn't always, it's the last thing. It's the last thing checked and implemented. We do have to have better process. Every individual technology we look at provides us a fairly good security layer, well vetted. Our mistakes happen, our breaches happen on mistakes most of the time.
Errors in configuration and errors.
Yes. But by reproducing these environments, continually knowing this is how it's done, we get better. By executing the same environment application and test in this idea of DevOps and continually delivering, I get a really good chance of guaranteeing what I see every day is what I'm going to see every day in production, not just in tests. I'm going to get the exact same type of security. That's what we're...
So practice makes perfect.
Practice makes perfect. We need to get better practice. To go back on to one topic, how's the DoD? They're behind. We know we need to begin this in acquisition. We're still in the waterfall model. Let's get a contract. Let's decide everything right now. 2 years later, we'll deliver. What happens? We miss our timelines. We want to change requirements at the end. It's not the same. Technology's switched. We need to invoke DevOps on acquisition. We need to, right off the bat, when we're acquiring new software, have them build it in our environment. Have them continuously give me updates. So my guys who will own this software, own these services, are using them, interacting with them every day from step one.
I attended Saturn this year. The keynote was a DoD gentleman, I forget his name, but he mentioned a lot of these tools. So I think they knew they were behind it, but they are, from what I see in his keynote talk, about how they're putting these tools to good use now and trying to speed up.
So you really want to acquire the update process at the same time you acquire the thing that you're interested in, right?
Honestly, the tooling's the easy part. The hard part is the beginning.
Using them effectively. It's true. There's a lot of really good tools out there, but if you don't have the process behind them, that's going to be a challenge.
The other things I would like to add that what you described before your question, Kevin, and if you kept the network configuration as the code itself as a versioning, so it's easy to the version all our network assets in a platform, so we know what we have, what type of version we have each network appliances or IDS or services, and we can really monitor it. If there is any security problems, any of the configuration, we can fix it once, then we can deploy all of them at the same time, which is automated deployment, and how the industry is doing it necessarily.
And you could go further. You could deploy heterogeneous ones if you wanted, or you could dynamically perturb them in some way. Or there's a variety of things you can do with all these tools available. And I think it's
actually a different approach to current methods of changing my network. We currently write custom applications and custom configurations that dynamically change. Well, why not have a random distribution of network changes?
Like take down some services, how the Netflix is doing right with the Chaos Mic right now. So they're taking down some services and try to make sure it's going to be work, depends on the threat, depends on some failure. So it's a failure like the threat. If you take the failure as a threat and take down some of the services and monitor it, how did that happen, how can we address that type of needs, how can we change dynamically?
So sort of a moving target defense is maybe enabled both at the application side and the network infrastructure side as it moves into the endpoint infrastructure in a way that we haven't really done before.
Certainly.
Yeah, that's probably right.
Well, gentlemen, we're about to wrap up. Thank you for the conversation today. If you're interested in DevOps, Hassan's team has a number of blog posts. They've done a number of webinars, so just search the SCI website. You'll see a lot of content developed from his team that can get you going on the right path. So that's going to wrap up our event for today. I really want to thank everyone for spending the day with us. As I mentioned earlier, the event has been archived. We will send out an email sometime within the next day or two with the location of the recording and the slides. We ask that you share that with colleagues, with your social networks, and spread the message here. We also we invite you to continue the conversation. There's a number of CERT LinkedIn groups. You can follow CERT or the SCI on LinkedIn and continue the conversations there. Ask questions of our various researchers and presenters today. You have their contact information. You can always email info@SEI. So we want to continue this conversation from the research that was presented today. And like I said, just carry it on. So once again, thank you for attending, everyone, and have a great day. Thank you guys very much.